Okay, let's take a look at page 104 and 105. Here we're talking about something in between what we've talked about before. So far we've talked about two extreme types of bonding. Ionic bonding is when a metal loses an electron to a nonmetal. Covalent bonding is when two identical nuclei share a pair of electrons. But also some of those covalent bonds end up being unevenly shared, and those are called polar covalent. So again, let's look at the water molecule, and the Lewis dot structure would look like this. So you have these extra electrons here, but you do have shared pairs, so that again is a covalent bond. But as it turns out, some atoms have more pull on shared pair of electrons than others, and that's called electronegativity. So when one atom attracts electrons more than another, it's said to be more electronegative. So here you can see values of electronegativity. Oxygen is here at 3.50 and hydrogen at 2.50. So the oxygen has more pulling power, higher electronegativity than the hydrogen. Just by the way, there's no units on electronegativity. It's just kind of like a number line, a number scale. All right, I think you can answer most of these questions on your own. But let me go ahead and look at one of the examples on the back. So when you get to this part, it wants you to identify whether bonds are ionic, polar, covalent, or nonpolar covalent. And I want to look at example B here. So sulfur and oxygen. So this isn't a complete molecule, but just if you consider a bond between sulfur and oxygen, would it be ionic, polar covalent, or nonpolar covalent? So you want to look at the difference in electronegativity. Sulfur is here at 2.44 and oxygen is here at 3.50. So it's really that difference that matters. So 3.50 minus 2.44. So that's equal to 1.06. So we would say that that is polar. And some people might wonder, well, where do you draw the line? So basically, this is a little arbitrary, but we say if the difference is between 0 and 0.4, then that is considered nonpolar. If it is between 0.4 and 2.0, that is considered polar covalent. And if it's greater than 2.0, then that's ionic. So this window is nonpolar. This window is polar covalent, and then greater than 2.0 is considered ionic. So for example, we don't have one on here that is hydrogen and carbon, but you can see even though those are different elements, their electronegativity is virtually identical to the number of significant figures we have here. So that would be considered nonpolar even though they're different elements. Anyway, I think you can do the rest of these questions on your own, but I will upload a copy of it with all the answers filled out for you to check your work later.